Good morning, good morning. Welcome to the second day of the Snapdragon Tech Summit. We had a live feed yesterday. We had 560,000 views on that live feed. That's more than all the days combined from last year, just on day one. And we trended on Twitter, on tech, worldwide, which is good, which means a lot of people checked that out. And we had another piece of good news. Yesterday, we made another standalone data call with our partner Ericsson here, which is great. And what I'd like to do is thank Ericsson and the engineering crew and the modem crew at Qualcomm for working so hard, all the people involved for working so hard to try to make that happen. Let's give them a round of applause. Yeah, another first, another first. And please check out the demos this afternoon. We have many of the innovative demos. You're going to see all of the capabilities of the 865. Please go check them out this afternoon. It'll be really good. And note to the competition, start taking notes as soon as I get off stage. Okay? All right, so without further ado, I'd like to bring out Keith Cresson, who's the Senior Vice President of Technology Product Management and Planning, to go over the 865 for the beast details. Okay? Thank you. Keith.
Thanks, Alex. Yeah. All right, welcome to day 2. All right, the room is packed, our schedule is packed, and you're going to see a beast packed with features. So I think it's going to be awesome, and as we go through today, let me know if you agree. Now, a quick show of hands. How many of you were with us in Maui in 2017 for our first Snapdragon Summit that we held in Maui? How many? So about half, about half. Okay, I want you and everybody to think back to 2017. Okay, 2017, what were you doing, where were you working, family, what was going on? And I'll provide a few hints. First, Bitcoin at the time exceeded about $17,000 per Bitcoin, and that was about the peak of Bitcoin. You know how I know it was the peak? Because exactly about a month after that, I went to CES, and my cab driver was telling me how much money he was making in Bitcoin. Now, if you go to CES and your cab driver gives you financial advice, you know what direction to head. That was 2017. 2017 was also the time that Google's AlphaGo beat the world champion from China using AI and deep learning. And that activity really woke up a lot of people to the power of AI. And AI really took off from startups to governments. One of the applications of AI, of course, is facial recognition. And I'm sure as you went through the airport in Europe, or you go to buy something in China, or enter the country in China, or even open your phone, you see facial recognition is virtually ubiquitous. Thanks to AI and deep learning, facial recognition really started taking off in 2017. 2017 was the production of the Tesla 3. Who would know that 2 years later it would be introduced to Cybertruck? Now, we'll do our very best to make our presentation today as entertaining as Elon Musk's Cybertruck, but it's going to be tough. That one's going to be tough. Snap introduced their spectacles. So what you see with your eyes is what's recorded. And tomorrow, when we cover XR, we're going to talk to you a lot more about what you see with your eyes and what can be recorded. And finally, the Nintendo Switch. The Nintendo Switch debuted in 2017. Interestingly, just last week at the US Black Friday, the Nintendo Switch was one of the top sellers for Black Friday. That tells you something about handheld gaming, and we're going to tell you more about handheld gaming later today. So that was 2017, but why am I talking about 2017? Because 2017, Q4 specifically of 2017, was when we finalized the definition of the Snapdragon 865. So it's 2 years ago that we finalized the definition of the chip that we're talking about today, and that's why we get so excited to come here in Maui and tell you about what we've been working on. In fact, while the definition was closed 2 years ago, we actually started working on the IP 3 years ago. So 3 years ago, in Q4 of 2016, when we had our Snapdragon Summit in warm New York City in December, we were working on the IP for the 865. We finalized the definition in Q4 of 2017. We sent that to engineering, who finished the design in Q4 of 2018, and now we're in production of the 865. So think about that timeline. Think about when we start working on IP, when we finalize the definition, how far ahead we need to plan. Now remember, at Qualcomm, we don't build a chip that's going to go into a few phones. We build chips that sell in hundreds of millions. They go into hundreds of flagship phones. And we have to work with the entire ecosystem. Now, if you look back at the timeline, this was before dual cameras. But look what happened. We had dual cameras, quad cameras, 4K HDR capture, and even, as Ben introduced yesterday, 108 megapixel cameras. Now, of course, the 865 had to be prepared for that world and more. Look what happened to displays. We started talking about percentages of screen-to-body ratios, 60 frames per second, 90 frames per second, 120 frames per second. Amazing in terms of displays. Think about security, facial payments, blockchain, ultrasonic fingerprint. Innovations from Google, Lens, AR Core. And think about the speed of the connectivity. Just a few years ago, we were talking about hitting the gigabit era. Now we're talking about 7.5 gigabits with 4G and 5G, including millimeter wave. So a ton of innovation. But I just wanted you to appreciate the timeline of us taking more than 3 years from the time we start working on the chip to the time we bring it into production. Now, it's one thing to define the chip. It's another thing to build the chip. So I could talk about building it, but I'm not qualified. But I know who is. Christopher Patrick, our Senior Vice President of Engineering for Qualcomm Mobile, will tell you about how our engineering team came to build the Snapdragon 865. Chris.
Thank you, Keith. All right. Okay, thank you, Keith. All right, good morning, everybody. All right, so, Keith took us back to 2017, but I'm going to take you even further back, to 2013. So 2013 is when we launched the Snapdragon 800. Today, as Keith mentioned, I lead engineering for the Snapdragon portfolio of products, but I myself actually worked on the Snapdragon 800. So that's a project that's near and dear to my heart. So in that project, we had a lot of industry firsts. One of the things, two of the features that were first in the industry was 4K video, so the first ever 4K capture as well as playback. Another first on that platform was LTE carrier aggregation, the first ever in the industry. So that was 150 megabits per second. Keith just talked about 7.5 gigabits per second on the 865, so a factor of 50 increase in the data rate. The Snapdragon 800, we were incredibly proud of it at the time, cutting edge at the time, supported 21 megapixel stills. The Snapdragon 865 supports 200 megapixel stills. So just incredible progress in just a few years, incredible advancements in technology. So let me tell you a little bit about how we go about designing the device. So as we kicked off the 865, as Keith described, it's really a 3-year journey for us. We have a set of goals for the platform. One of the things we wanted to achieve on the 865 was to have a best-in-class video record solution, 8K resolution with a continuous zoom experience that rivaled, for example, even a very large DSLR with a large mechanical zoom. So the design was to have multiple sensors, a total of 8K resolution, as we said, seamlessly zooming within each of those sensors, but also switching between those sensors in a way that appeared to be a continuous mechanical zoom. Another goal was, as we said, full 5G global capability, 7.5 gigabits per second, including millimeter wave, sub-6, SA, NSA, all working together, real 5G. So that for us is a 3-year journey. The first year is really about the IP, the technology, the different building blocks that make up the Snapdragon platform. For example, if you think about that 8K recording use case, we have to, of course, enhance the Spectra ISP, the image signal processor. You'll hear today about a new generation of ISPs, the gigapixel ISP. Okay, but also, as we think about that zoom case, we want to zoom within a single sensor, a single image, single camera, but we also want to seamlessly switch between those cameras. So now we bring in the GPU, which gets involved and helps us match the images between those two different sensors. It's possible, for example, for that same 8K camera use case, that we want to do advanced processing, image processing on the back end. So for example, we may want to process skin differently when we process cloth. So that means we need to have an algorithm, we need to have circuitry within the Snapdragon 865 to do real-time tracking, to in real time differentiate between the portion of the image, even though it's moving, that is skin, and the portion that is cloth. So that requires machine learning techniques. That required enhancements to the Hexagon DSP. Anyway, so we have all these different building blocks. And here I focused on the 8K use case, but you can imagine we have a broad array of different use cases, different technologies, going all the way from modem, all the way to antenna, power management, different technologies, including, for example, fundamental enabling techniques like transistor technologies, packaging technologies. So we have this very diverse array of technologies that we all bring to bear on the Snapdragon that will ultimately become the Snapdragon 865. So in fact, at Qualcomm, we're very proud of our 30-year history of fundamental research to drive different technologies that ultimately become part of our Snapdragon platform. Okay, so that's really the first year. It's really coming up with these building blocks, the different components that ultimately will make up the Snapdragon. We've also finalized, as Keith said, we've finalized the requirements, exactly what do we want this platform to do, working with our customers, working with our partners. So now in the second year, what we're focused on really is the system. It's putting together these building blocks and coming up with a coherent system. So when I say system, really it's three different levels we think about. So the first level is the chip, the system on a chip. So we've discussed, for example, that 8K use case requires the camera ISP, requires the GPU, it requires the machine learning accelerators, all to work together, to come together to form that 8K use case. But it gets more complicated than that even very quickly. For example, we need security processors to manage that data and make sure that, for example, an application that's not authorized to access the camera, it doesn't get access. We need to make sure that despite everything else happening in the system, that we get the data where it needs to get efficiently and make sure we have no drop frames, we have the best possible performance. So anyway, so this is the first level of system, the SoC. Okay, so now you can zoom out and you can consider the device, the chipset. So we have the Snapdragon SoC, but around it we have, in this case, the modem, we have the RF, we have components all the way through power amplifiers, antenna modules, we have power management circuitry, we have audio circuitry, we have a broader chipset that all works together. So for example, if you think of that 8K use case, we need to make sure we get energy, we get power to the right portions of the system to energize the different portions of the system and still have the minimum consumption on the battery. We need to make sure for that 8K use case, as we generate heat, that heat moves out of the device, moves smoothly across the entire handset. We need to make sure it can fit in the incredible form factors that our customers are driving towards in 2020. So we have to make sure the package, all the components all work closely together. Finally, the last level of the system is now that handset really exists inside a broader ecosystem. So now you can think, for example, maybe I want to take that 8K use case. I want to do live streaming of my 8K feed because I'm at a Steve Aoki concert, and I want to share that content with my friends. So now I need to bring in not just that SoC, not just the chipset, but now I need to operate with, for example, if I'm doing streaming over millimeter wave, I now need to operate with Verizon's millimeter wave infrastructure. Or I need to access cloud storage data to, for example, come up with AR live content. So that's the third level of the system. So in this second year, really, we're putting together each of these different levels of system, doing careful design, doing prototyping of the platform. That really takes us to the end of that second year now. We've carefully designed, carefully figured out how the different three levels of the system will work together. We have prototypes. We finalized even very low-level requirements. That takes us to the next year. So finally, on the third year, we're finalizing the design. We're finalizing the design of the hardware, software, at each of those three levels of the system. And we're testing it all, testing and optimizing it all. You can imagine, again, we have an 8K camera, but we also have very low power camera scenarios. We have many, many different combinations. as you think about different multimedia functionalities, different AP functionalities, different modem capabilities, you'll quickly find, we have not tens, not hundreds, but really millions of different use cases and scenarios. Alex said yesterday, our job at Qualcomm is to manage complexity, and that's what we do here, is we make sure that across all these different combinations of scenarios that we provide the best possible user experience. So it's this tuning and optimization, careful testing is what we're doing in the third year. The other thing we're doing in the third year is engaging beyond just Qualcomm. We're bringing in technology partners from across the industry. So we provide a platform, but we partner with different people across the industry to bring in different kinds of content, different kinds of techniques to enhance our platform and make it even more interesting, even more innovative. Finally, the most important thing we're doing in year 3 is we're working with our customers. Each customer has a unique vision for how to take the Snapdragon platform and bring new user experiences to the final end customer. So yeah, it's our job to work with them in this year 3, to customize, to provide all the different accelerators that we have, to work with them to enhance it, to bring those experiences to life. So really that brings us to the end of year 3, to finally having the Snapdragon 865, to be able to come here to Maui and to share it with all of you. We have an incredibly talented group of people at Qualcomm that all work incredibly hard to make sure that we have the best possible solution for the industry. We take a lot of pride in it, and we're very happy to share it with you today. So it takes 3 years and an amazing team of 10,000 engineers to bring the Snapdragon 865 to life. So I'm very happy to be able to be here to share it with you. Thank you all. Thanks very much.
Thanks, Chris. Thanks, Chris. All right. When we defined it, you kind of know how we defined it, based on what Chris said. You probably want to know what's in it. So that's probably a good thing we'll cover. So let's start talking about the platform itself before we get into the details of the 865. Of course, the first key component is the cellular connectivity. You heard some of this yesterday. You heard some of it before that. The key thing on the cellular connectivity is we designed it as a system. We designed the RF front end, and the modem itself as one complete system. That's the only way to get the best performance, to get the best power, get the best connectivity for users. So this was defined all in concert with one another. It's our 2nd generation 5G modem. Again, modem to antenna, and it's only through this system design that we can offer innovative features like envelope tracking or smart transmit or power save. 5G is extremely complex, and so it's very hard to piece together different parts of the ecosystem. That's why you need to define it as a system. So this system, of course, supports sub-6 and millimeter wave. We think sub-6 and millimeter wave are going to be required, right, as time progresses, just like Cristiano showed. That's why we have sub-6 and millimeter wave, both in the X55 that's discrete and the integrated X52 that's in the 765 platform. We support dynamic spectrum sharing, which is vital, so that spectrum that's currently used in 4G today can be reused for 5G. We support carrier aggregation. We support carriers worldwide. If you think about Qualcomm, when someone launches an 865 with an X55, they don't want to launch in one country. They want to launch worldwide. We need to support the entire ecosystem at one time so we can launch tens of millions of units. And consumers that buy those premium devices are going to be future-proofed wherever they go in the world for years ahead. In short, the X55 is the world's best modem. Now let's talk about the Wi-Fi. So the Wi-Fi has been previously announced. It's our 6800 mobile connectivity. It's in 14 nanometer. This is Wi-Fi 6. Supports up to 1.8 gigabits per second, which is fast. Not quite as fast as the cellular guys at 7.5 gigabits per second, but I don't want to take anything away from Wi-Fi. 1.8 gigabits per second, that's with simultaneous operation across 2.4 and 5 gigahertz bands. Now we have a world where people want to upload movies, upload videos. That's why we're the first to support uplink multi-user MIMO, up to 8-way for real-time video gaming and sharing. We support integrated Bluetooth 5.1 and aptX. So we support the super wideband voice. That's 32 hertz voice over Bluetooth for crystal clear audio. And finally, of course, many want to use wireless earbuds. So we support True Wireless Stereo Plus. So our devices can connect to discrete Bluetooth earbuds independently, providing up to 2x range and 75% improvement in battery life. We have the best modems, cellular connectivity, and we have the best non-cellular connectivity. Now, how does that support the 865 platform? Let's talk about the 865 in more detail. So the 865 is built on TSMC's 7-nanometer process, N7P, unlike the 765 and the 765G, which is built on Samsung's latest process, 7-nanometer EUV. So we're using the latest high-volume processes from the leading foundry vendors, both TSMC for the 865 and Samsung for the 765 and 765G. That's the process they're on. Now let's talk about the chip. First, the Spectra CV ISP. We introduced computer vision into the ISP for the first time with the Snapdragon 855, and we've made material enhancements with the 865. We're entering a world of 100, 200 megapixels. We're entering a world where the Olympics are coming and people want to record and capture in 8K. So we redesigned the capture for higher speeds and lower power, supporting up to 2 gigapixels per second. So as you're recording 4K video, and that 4K is basically 8 megapixels on your screen, and you hit capture, you can capture 64 megapixel pictures at 30 frames per second. 30 times a second, you're capturing 64 megapixels. Super impressive. Now, we didn't do that by just cranking up the clock and burning a lot more power. We actually redesigned the pipeline, so now we process 4 times the amount of pixels per clock. We also have a new engine for video analytics. This engine for video analytics is used for object detection and tracking. It provides 25% lower latency and a 50% power reduction relative to what we introduced in the 855. And also, we have HEIF, our high efficiency image format, which we introduced in the 855. And again, that's not just for compressing images up to 50%, it's for storing metadata, storing depth information and color information. And Judd is going to talk about our industry-leading camera in a lot more detail. Second, let's talk about our Adreno subsystem. We have the most efficient graphics core in the world. Now, there's different ways to get higher graphics performance. One is just to crank up the clock. We could do that. That's not our goal. Our goal is to be the leader in sustained performance. Our goal is not to be first in benchmarks and then 1 minute later not be first in benchmarks. Gamers require consistent gameplay. We also don't want to design to the thermal limits. We don't want one phone to perform materially differently from another phone. We provide a solution for hundreds of phones. So we don't want your performance in Alaska to be different from your performance in Maui. Sustained performance is our goal, and sustained performance is where we have leadership. And if that's surprising in any way, just look tomorrow when we talk about our VR design wins. Virtually every device in the world powered by VR uses Qualcomm. Why? Because every pixel in VR goes through the graphics pipeline, right? It's important for leadership in mobile. It's important for leadership in XR. Now, on the Adreno 650, we've improved the 600 series graphics yet again, offering a 25% improvement in graphics rendering for better gaming, a variety of different applications for AI. We'll talk about that a bit more. And we optimized the design point not for 60 frames per second, but for 90 frames per second. And it's at 90 frames per second that we get 35% increase in power efficiency with the new Adreno graphics. We have enhancements in video, which Judd will talk about, and we also have enhancements in our display processing engine, where we can use local tone mapping to improve gaming. Now, if you think about gaming, it's one thing to have a great GPU, but you also have to have great software in enabling and use other portions of the chip beyond the GPU to have a great gaming experience, and Leilani and Todd are going to talk about that later today. Let's move to the CPU. We've moved to the latest core from ARM, the A77 core. We have a very similar configuration from what we had in terms of caches and clocks as we had on the 855, which served us very well. We have a prime core that's A77 that runs at 2.84 gigahertz. We have 3 performance cores, also A77 based, that run at 2.4 gigahertz. We have 4 cores that are A55 based at 1.8. Now, based on ARM's design, they all have local L2 caches. We have our biggest cache in the prime core, and they all share a L3 cache. We've doubled the L3 cache relative to the 855 from 2 megabytes last year to 4 megabytes. The Cryo CPU subsystem is extremely powerful and extremely power efficient. Let's move to Hexagon. AI is incredibly important. The next section, you're going to hear a lot more about AI and AI applications. We have to improve AI at a rapid pace, and we've done that with the 865. We've completely redesigned the tensor accelerator that was in the 855, bringing 4 times the amount of operations per second in the tensor accelerator in the new Hexagon, and at the same time, bringing a 35% improvement in power efficiency. So AI, 4 threads can run in vector processing, 4 threads in scalar processing, and an extremely powerful tensor processor for AI and signal processing. Now, if you take it all together, how do you process AI in the chip? You can do AI in the CPU, or more efficiently, AI in the GPU, or more efficiently than that, AI in the Hexagon. And you add it up, we support 15 TOPS. So think about that. A chip about the size of your thumbnail supports 15 trillion operations per second just in terms of AI processing, more than double the performance of our Snapdragon 855. Now at times, rarely, but at times today, we actually need even more bandwidth, and we've provided it. We support LPDDR5 running at 2.7 gig. That's about a 30+% efficiency over the peak speed of LPDDR4. Now, we support LPDDR4, we still do, and 5. It's the OEM's choice on whether they want to use LPDDR4 or LPDDR5. And this is all supported by an additional 3 megabyte system cache. So we have almost 6 megabytes of cache in the CPU. This is an additional 3 megabytes of cache that's available to the Adreno, the Hexagon, and the Cryo. All of that forms the most powerful AI chip for mobile on the planet. Now, we talk about this awesome performance. Well, what about extremely low power? Whether it's cloud vendors, OS vendors, ISVs, they want contextual information. Just like when you're laying out on the beach and your eyes are closed, you're in power down mode, but you can still open your eyes and see, you can still hear. We want the chip to be able to have the same capability. So we have low power engines in the 865. We offer low power audio, low power voice, low power sensors. These can run at less than a milliamp. So you can have multiple wake-up words, whether it be from Google or Amazon or Baidu and others, running at extremely low power. Also, how do you see with low power? What we are offering is a separate chip, a low power camera subsystem that runs at less than a milliwatt. Less than a milliwatt. So it's a system level solution. It's our chip partnered with a sensor vendor, system level solution. And if OEMs want an always on camera, maybe they want to test the ambient light or recognize the face or recognize a QR code or many other applications, we can provide it with our low power camera subsystem that can be used on the 865 or used with the 765. Now, powerful and power efficient hardware is important, but so is the software. So we offer a scalable sensor framework, highly scalable, that we can take sensor information, audio information, camera information, location information, merge it, fuse it together, and offer smart APIs. APIs that can be used for things like environmental settings, to know if you're in a conference room, or in a car, or on a train, or security, to know that you're secure based on your location, and your voice print for device unlock, and many, many more applications based on our scalable framework. So on one side of the beast, 865, you have the most powerful chip on the planet for a mobile system. On the other side, we have extremely low power options for voice and signal processing. Now, I've talked a lot about a high level at the chip, except for security. That's the one thing I haven't described. We show security as a block, but security actually is a lot more complicated than that. So let's talk about security a bit, but instead of my doing it, I wanted to introduce our Senior Director of Security at Qualcomm, Jesse Seed, to walk you through the security enhancements of the 865. Jesse.
Yeah. Hello. Tell me if this sounds familiar. You're at the airport on the way to Hawaii. You scan your mobile boarding pass as you move through security. Maybe buy a cup of coffee on the way to the gate, and flip through pictures of the kids as you wait for your flight. Now, as you use your phone in your day-to-day life, do you think about how your data is being protected? Now, if you don't, that's OK, because we do. At Qualcomm, for over a decade, we've taken a system-level approach to security. Let me give you an example. Face authentication. Now, this is a highly complex use case that involves multiple subsystems throughout the SoC, and we protect the data at each stage. As a face map enters the sensor and then travels into the Spectre ISP, we begin the first stage of our protected pipeline, using dedicated hardware for access control called System Memory Management Units. This hardware ensures that even if malware is present elsewhere in the system, the malicious code cannot copy out of the protected region. Next, the data travels into the Hexagon DSP for further processing by machine learning algorithms. We've created a secure domain within the DSP to ensure that even sensitive biometric data can benefit from low latency and low power compute. And we even protect the machine learning algorithm itself. Finally, the fully processed data moves into the Qualcomm Trusted Execution environment, where it's matched against the biometric template resident in secure storage, and the final verification result is passed to the application. Now notice that at no time did any of this data have to leave the device to be processed on the cloud. Everything happened on device and in a fraction of a second. Ensuring security while maintaining performance takes Qualcomm expertise. Now, in addition to strong user authentication, and unique to Snapdragon, we can also provide hardware-based device attestation, which allows for relying parties, like a bank on the back end, to not only strongly identify the user, but the device as well, which adds an extra layer of security for high-value transactions. It's worth mentioning that there's no standard for how to protect a complex use case like face authentication. So while other SoC vendors can support face-auth, ask yourself if you trust them to protect it properly. So that's just one example of the many use cases that we can support with Qualcomm platform security. We have many other features, things like secure boot to ensure software integrity for the system, and advanced cryptographic engines to keep everything moving at the speed of Snapdragon. In addition to our platform-wide security, we also offer a highly isolated, secure processing unit for high-assurance applications. Now, earlier this year, we announced that the Secure Processing Unit, as part of Snapdragon 855, was the world's first mobile SoC to achieve smart card level security certification, which meant that it's now possible to support security features that previously could only be supported with discrete ICs, SIM cards, or secure elements, fully integrated into the Snapdragon. And today, we're very pleased to announce that the Snapdragon 865 will be the world's first integrated dual SIM, dual standby solution, which means that we'll be able to replace 2 physical SIM cards, or eSIMs. And we'll be demonstrating this capability in the demo area later today. Now, in addition to all of our robust hardware and firmware security features, we also partner very closely with our friends at Google to ensure that the latest and greatest Android security features shine on Snapdragon. To tell you more about this, I'd like to welcome to the stage Sudhi Hurley, Android's head of platform security from Google. Sudhi.
Thank you, Jesse.
Sudhi.
Hello, everyone. My name is Sudhi Hurley. I lead platform security for Android at Google. We're actually very thankful to have a very strong partnership with Qualcomm to improve the state of Android security. Over the last year, we worked very closely together to raise the bar for what Android and the silicon, Snapdragon silicon can do to make our users feel safe and secure. We've jointly created a vulnerability rewards program to raise security awareness and further research in security. And Qualcomm was the first vendor to support our new Strongbox hardware-backed secure credential API. And we are also partnering very closely to improve kernel security. Together, we have worked on control flow integrity, bounds checking, integer sanitizers, etc. In addition, we are also working on improving detection capabilities for memory safety in the kernel by partnering on hardware ASAN capabilities. Next. But security by itself is not as glamorous, as we'd like to believe. Security also needs to be an enabler to make other parts of users' life more beneficial, more helpful. And so,
yeah, exactly. What we like to say is that security is really the key to going from this to this. And Sudhi and I are very excited today to announce that we're just a step closer in that journey. So, quick survey, how many of you have ever showed up to the airport and realized you forgot your ID? It's a terrible, terrible feeling. Well, we're working on solving that as well, because today we're very excited to announce that Snapdragon will be the first mobile SoC to support Android Identity Credential APIs, which means that mobile driver's license and electronic ID will be possible with Android R. Thank you. Thank you. And we invite you to check out this cool capability in the demo area after the keynotes. Thanks very much, and now back to Keith.
thank you.
Good job.
Thank you.
Good job. Thanks a lot.
Thank you. Oh, sorry.
Thank you. Awesome. Now I can leave my wallet at home next year. And security is glamorous. Who doesn't think security is glamorous? Come on. Security is glamorous. We all know that. All right. So we just had one walk on Google. We didn't have any demos, but sit back. We have a lot of demos, a lot of walk-ons coming in, some exciting stuff coming over the next 3 presenters. So you're just getting a taste of it. Hopefully you get an idea of why we think Snapdragon is the most secure processor, working together with Google, the most secure platform. So if you want to make payments, you have biometric information, you know why you need to go with the Snapdragon. There's not a lot of system specifications for security. We take security extremely seriously. So now we're going to talk about 3 main areas. So 3 groups of speakers coming out. We're going to talk about AI, we're going to talk about camera, We're going to talk about gaming to show why Snapdragon 865 is the beast that Alex mentioned yesterday. So with that, let's talk more about AI. I want to introduce Ziad Asgar, our Vice President of AI and Strategy. Ziad.
Thank you, Keith. All right. You just heard Keith talk about all this amazing technology that we are packing into the Snapdragon 865. I'm going to focus on the AI use cases and experiences that 865 will bring to the front. Now, at Qualcomm, our vision has always been to really make all the devices that we have, that we enable, to add more and more intelligence to them. And as we add more intelligence to them, we give them the ability to really be able to understand their surroundings. And as they understand the surroundings, they get the ability to be able to reason based on that data and actually act in time. That is our vision, and we are moving towards making that a reality. So a decade ago, when we started our AI research, to where we are today, we have more than 1 billion, with a B, 1 billion devices enabled today that use Qualcomm AI technology. So what can AI do on our handsets and our devices today? Now, you guys are all familiar with this use case, right? You walk into a room and you listen to some music. The device, you have to take it out of your pocket, you have to unlock it, you have to go to a certain app, and then the device tells you what song is playing. By the way, that song was from one of our Qualcomm musicians, Jerry. So once it figures it out, it's able to tell you that. But look at how much of a deliberate attempt this is to understand what's happening. Now, the fact that we can run these neural networks at the lowest power possible on the device, it means that we are always able to detect what song is playing in the room. And now this experience becomes completely seamless. And technology really works the best when it is invisible to the users. These are just two use cases. And by the way, this use case, what really enables it is the fact that we can run these neural networks, these AI cases, at the lowest power possible. Another use case that I use personally a lot, and that is speech to text. So this is use case where you talk into your phone, and basically as you talk into the phone, it changes that into text. Now in the past, the way this used to work, you would say something in the phone would package that audio, send that over to the cloud, and the actual recognition, the actual conversion would happen in the cloud. But now that we are packing so much AI capability onto the product, all of this inference is actually happening on the device. And look at what a difference it makes. The difference in experience, the difference in terms of latency is very, very pronounced. And what makes this case work is the fact that we have a lot more peak AI performance available on the device. So we can already do this, but we can do a lot more. I mean, this is just a snippet of the use cases that we are enabling today with our AI products. Jesse talked about it. If you look at face authentication, it's a huge phenomenon in many parts of the world. And the way we make it work is by using AI on the device, which makes it much more accurate and a lot more cheaper to really enable on the device. You can also look at completely new use cases where the imaging experience has completely changed from what it used to be on the device, right? You can imagine, and Judd will come later to talk about it, but now you can take pictures in the lowest illumination possible. That is because of application of AI for those camera use cases, as an example. So really, we can already do all this stuff with our current products. So what can the Snapdragon 865 do? Now, with our latest platform, we expect to take these new experiences to the next level. On the two screens beside me, you can see that everything that I'm saying is being transcribed into English, and then it is further being transcribed into Chinese. And all of this is happening on the device. This is the power of Snapdragon 865 and AI on our new platform. Let's look at the details as to how we're making this work. By the way, just imagine how powerful this was, right? Right over there was the device, and this use case was running on the device. There is no data that's being sent to the cloud. All of this is happening on the device. And to quote Alex, this is the beast mode for AI, by the way, right? So really, really amazing stuff. So the way we are making this work is we have actually focused on three key pillars. We have best-in-class hardware that Keith talked about. We have amazing software. And we have actually a third layer, which is the developer tools. And by the way, on that use case, we partnered with UDAO, which is a great partner for us for the translations. Now, I want to start at a higher level. If you take a look at all the blocks that are lighting up right now, these are all the blocks where we are actually applying AI technology today on our chips. So for example, we take our world-leading 5G modems, and we can actually improve the reception and the quality of throughput and the experience by using AI. We can actually take this AI technology and vastly improve the power consumption of our solutions. And more than that now, we are actually applying these AI techniques to actually implement and produce these products, the silicon products, by using AI as an enabling technology as well. So really, we look at AI as a horizontal technology that spans across everything that we do and all the products that we make. Now focusing more on the 5th generation AI engine that Keith talked about, but I want to give you a little bit more detail over here. So as you know, we always take a heterogeneous approach to AI, right? We have multiple different engines where we allow you to do the trade-offs between precision and power. So in this case, we have more than doubled the floating point capability and AI performance on the GPU. On the Hexagon processor, we have quadrupled it on the Tensor processor. But what we have done is something more than that. Just notice all the use cases that I've already showed to you, right? These are all concurrent use cases. What does that mean? It means you're moving in a lot of data into the device. That means a lot of weights, a lot of activations, and that translates into power. So what we have done is we have implemented a completely new and unique technique that we call deep learning bandwidth compression. What that allows you to do is to take this data and compress it by a factor of 50%. Just imagine now, right? That means you're moving in 50% less data into this block now, which translates into a huge amount of power savings. Very powerful technique. And by the way, this is completely lossless. So this is no trade-off in terms of accuracy when we do that. And of course, as Keith talked about, for these super intensive use cases, we have LPDDR5 where we can move in yet more data into the device than ever before. You know, we get this question many a times as to why we have done the architecture of our Hexagon processor in the way that we have done it. To be able to implement AI properly onto the device, you need to be able to execute multi-dimension data structures. You know, you can have a zero-order scalar. You can have a first-order tensor that we call a vector, or a second-order tensor that's actually a matrix, and so on. And you can see that this is exactly how we have implemented our Hexagon processor. Second point, if you look at that representative neural network that I show at the bottom, there are certain parts of it that are very well suited to run on the scalar processor. There are certain parts of it that are very well suited to run on the vector processor, such as the fully connected layers. And then the bulk of the network, which is the pooling layers and the convolutional layers, they all run on the tensor processor. That's why we have architected it the way we have done it. And those who don't have this sort of an architecture would find it hard-pressed to run some of this part onto a general purpose processor, which would consume a lot more power. All right, so we talked about it from 845 to 855. We did more than 2x improvement in AI processing. And like Keith showed, as we've gone from 855 to 865, we have yet again more than doubled the processing capability to get to a whopping 15 trillion operations per second. And by the way, that's 5 times of what we were able to do just 2 years ago. That's a massive improvement in terms of AI processing capability. And you know what, as I'll go through the talk, you will notice why we need this massive amount of AI capability on the device. All right, so you know, we hear a lot of people talk about peak performance. So what we have done over here is we actually look at AI performance on multiple different silicon vendors. And what you notice is we looked at 4 different representative classification networks. And if you look at the data, you will realize that our closest competitor is less than half the capability that we have. That's an amazing amount of peak capability that we've packed into the 865, and you will see why we need all of it. Now, the second part, if you remember in the beginning of my talk that I mentioned, to make this work, you need to have best-in-class power as well. So on this slide, what I'm showing is really inferences per watt, which means how much AI processing can you do for a given amount of power. And if you will notice, in this case as well, for certain benchmarks, such as MobileNet, you will notice that we are able to do double the amount of work for the same power consumed. That is what makes 865 the best AI platform out there. Power. Remember, for a mobile device to do AI, for these sustained use cases, for these concurrent use cases, you need the best-in-class AI at the lowest power possible. We, of course, haven't stopped there. We covered the AI engine, which takes care of all the very intensive use cases. Now, for always-on use cases, we have this amazing sensing hub that is AI capable. So what does this really enable? Now, you can envision that the device is always listening and can actually listen for certain sound-based events. Is there a sound of a shattering glass? Is there a sound of a scream? And it's able to take action based on that. This is exactly aligned with the vision that I talked about in the beginning. Similarly now, not just can you do the keyword detection, but your device at very low power can actually tell you if that audio is coming from the right user. So it's not just unlocking based on a keyword, it's unlocking based on the fact that the voice or the sound is coming from the authorized user. And then lastly, your device now knows if you're walking, if you're in the car, and it can take certain actions to make sure that it's safe for everybody on the road, and including you, by the way. And that's really a great feature as well. Thank you. So this is the hardware story. We are very pleased with what this solution is going to be able to do, but you cannot have the best hardware without the best software to go with it. And to talk about the software enhancements that we have made on 865, I'd like to call up my colleague, Jeff Galhar, who leads AI software at Qualcomm. Jeff?
Thank you. Well done. Excellent. So excited to be here. Honored to share the next piece of the puzzle, how we bring AI to life. So you've heard about the incredible hardware on Snapdragon 865. You've heard about all 2 days, Alex talking about it, billions of devices enabled. But let me tell you, it's only part of the story. The software goes with the hardware to unlock all the magic. So I'm going to take you through that. Now, we've talked about use cases in your device today already. Undoubtedly, you have got cameras doing AI, voice doing AI. We're going to take you through some of that. But just know it's already in your device, and 865 is going to make it so much better. So, the complete software stack. I'm going to take you through every layer of this software stack. I'm going to tell you how we enable it, why we enable it, who it helps, and how we've made it better on Snapdragon 865. So talking about your favorite social media app, we'll talk about that in a minute. I think maybe one of the most important first things is our partners. We have 25 or more partners that help us deliver this incredible AI solution on Snapdragon and on Snapdragon 865 particularly. And they span the whole range: audio, video, sensing. You'll see some examples, some demos on the stage in a little bit. This is the top layer of the stack. This is where we, working with our partners, help them move their solutions from CPU to GPU to hexagon, depending on the use case. This is where we help them really specialize on Snapdragon and produce the most incredible experiences for our users. So, thank you to all partners who are here and who are in the audience and helping us with this show. Now, frameworks. So kind of technical stuff here with AI and AI software in particular. You saw Ziad explain all these tensors and everything, so we'll try to simplify it a little bit. Frameworks. This is the toolkit that powers training and designing these AI solutions. So you're an AI designer, you're going to use TensorFlow, or you're going to use PyTorch, or you're going to use one of your other preferred design networks, and you're going to use Onyx as an interchange format. Now, with Snapdragon, our goal has been for a long time to make it easy to be a developer, to get onto Snapdragon, and to do it with the least amount of friction. We want to make these complicated, difficult, powerful things simple, and we're going to make it fast on Snapdragon, and our software complements our hardware. So these are the frameworks. You train, you build, and you evaluate your AI solutions with these frameworks. Now, that's all done in the cloud. Now we get to the exciting stuff. Okay? We were the first to introduce a mobile-oriented AI software toolkit for AI on mobile devices, and we're in our 5th generation with the 5th generation AI engine. And it's still the most popular way to get onto Snapdragon and mobile devices. And the most powerful AI chip in the world has the best software in the world to go with it. And you'll see in a minute some of the key enhancements that we continue to make with the Snapdragon Neural Processing SDK. But, as we always do, we work with our ecosystem partners. Google's a great partner. We had just Google on stage a minute ago. Android neural networks is becoming one of the open access platforms for neural networks on Android and specifically on Snapdragon processors. And as a result, what these two working together enables is unparalleled developer access for first and third-party applications on Snapdragon, on the best AI hardware in the world with the best AI software we can deliver. So the runtime layer, super important. Let me take you through some of the key features. And there are a lot of features that we don't have time to highlight. With the Qualcomm Neural Processing SDK, improved performance, power, performance, access, features. That's what we focused on. We release it every month. We update it all the time. We work closely with our partners and our OEM partners to deliver the best-in-class solution. More networks, more performance, and working with Qualcomm AI Research, innovations like data-free quantization. So that's the Qualcomm Neural Processing SDK. How about the Android neural networks, okay? So it's been a couple years in development. It's already shipping now on Snapdragon 865 with Android 10. We focused on accelerating all of the key use cases. So 3 times the number of hardware-accelerated operators or features are enabled on it, and it's optimized for solutions like Google Speech and Google Lens. So key takeaways. 2 runtimes, but wait, there'll be one more. 2 key runtimes. The first from Qualcomm, the Neural Processing SDK, partnering with ecosystem partners on Android Neural Network. Easy access, best features, best performance. Now, what happens when you do this? What happens when you have the best hardware and the best software? When we work with those partners on our OEMs to move those solutions from CPU to hexagon, we see 3 to 5x speed improvement, power, performance. This is what makes those AI use cases come alive. Right? So, speaking of, one more thing. Again, working with Google, ASR is automatic speech recognition. So this is going back to what Ziad talked about. This is that translation case. This is what happens when you move that translation case from the cloud to mobile. So working with Google, enhancing Android Neural Networks API, moving it from CPU to hexagon on Snapdragon 865, 3x power savings. This is always, all day speech translation so that you can do hands-free for real in the car. And 30% lower latency. So this is making it more responsive, more interactive, more real time. Very powerful stuff. Now, you heard Alex, I think, talk about managing complexity. And I already discussed earlier how incredibly complicated these frameworks are and how many features are really packed into them. And the innovation never stops. So today we ship 160 tuned for Snapdragon operators. When I say operator, I mean these complicated mathematical functions that exist in these frameworks. I mean all those things to make the tensors work better, all powered for Snapdragon on the platform in the runtimes. But innovation never stops, and AI is an incredibly innovative space. So announcing today, we're going to unlock the power of Snapdragon with user-defined operators. We're going to go from what's already in the platform, tuned for Snapdragon. We're going to enable anybody to build their own operator. Use OpenCL, our supported platform on Adreno, or use the Hexagon SDK and build it for Hexagon. Now you can differentiate, you can enable, you can do your own thing, plug them into our frameworks, and you're going to get the power of Snapdragon designed by you. Thank you. Thank you. Now, before we leave the runtime layer, one more thing, TensorFlow Lite. Now, if you're a TensorFlow user, again, I said we want to not get in your way. We want you to be able to pick the framework that you want to use that works for you. Now, if you're a TensorFlow user in the cloud, you're training in the cloud with TensorFlow, TensorFlow Lite would be a very natural way for you to get on mobile. So working again with Google, we thought, how do we get even more performance out of this incredible hardware and this incredible software? So we said, well, what if we strip away the runtime and we go right to the metal? What if we enable a library that runs directly on Hexagon? And now you can just go TensorFlow Lite, you TensorFlow in the cloud, TensorFlow Lite for mobile, and boom, directly on the best silicon with the best software in the industry, and deliver 3 to 5x performance improvement to your users. Wouldn't that be totally cool? So that's what we did, introducing Hexagon and nDirect. But what if it wasn't just for TensorFlow Lite? What if other solution providers could also use this access? So if you want to be an application layer. You want to use one of our runtimes, use our runtime layer. You have your own framework, you have your own solution, you're a third-party developer, a third-party app solution provider, Hexagon and nDirect. The full power of Snapdragon, 3 to 5x performance enhancement, delivered on our solution. So very excited about that. Now, Keith talked about it. Even better is when you can actually see it run. So a little anecdote. My daughter's studying abroad in college, and she uses these social media apps to document her life and record her stories and share her experiences. And the best exciting part when I was talking to her is I said, we're going to have these guys on stage. We're going to have somebody on stage that's already using Hexagon and nDirect. So if you'd help me welcome, please help me welcome Yuri Manisturin, Senior Director of Engineering at Snap. He's going to come on and show Snapchat, right, the product that Snap produces, running with Hexagon and nDirect. Please help me welcome Yuri. Your show, man.
Thank you. Hi, everyone. It's a pleasure to be here with you today. I want to share some exciting stuff we are working with Qualcomm on. But before that, some context. While cameras were created to capture memories, Snap is reinventing the camera to be a platform for communication, entertainment, search, and commerce. More than 210 million daily users, creating over 3.5 billion snaps daily, making it the most used internet-connected camera in the world. And on top of that camera, we have created widely popular creative tools, such as lenses. You can see some examples on the screen. The key piece of technology there is AI, or machine learning. Today, we want to share some major improvements to the machine learning we've been working with Qualcomm on. Performance. Performance plays a critical role in the experience. To be able to record fine quality video, the frame rate should be close to the 30, or experience will be less compelling. Utilizing Hexagon, we were able to achieve 4 times speed up compared to the CPU inference, and 2.2 times speed up compared to the GPU, meaning we can finally hit smooth 30 frames per second on the Snapdragon 865. We detect the Snapdragon hardware and utilizing Hexagon Direct to perform this speed up. Maxim Gusarov, our lead engineer of mobile ML inference, will demonstrate these improvements. You can see Maxim's appearance as it's now, but with one press of the button, he can magically change it. The difference here is that this is not machine learning for the computer vision. Thank you. This is a generative neural networks that directly transform original image to the result one. And the real-time effect is possible with the power of Hexagon. Thank you, Maxim. Now, we are releasing these lenses earlier this year, and over 200 million of people played with these lenses in the first few weeks. Today, we are able to continue building on this technology. With the help from Qualcomm, we can deliver great experience to our users, and much more things are going to happen soon. Thank you very much, and let's welcome Ziad back on stage.
Awesome use case. Thank you. You can see, right, how cool this is, right? The improvement from just 10 frames per second to more than 40 frames per second by using the power of hexagon processor. Absolutely amazing. Now, we just talked about 2 pillars. We have more. So we have added actually a 3rd pillar to actually improve the AI processing even further on 865. We're calling them the developer tools. And essentially, we call the toolkit the Qualcomm AI Model Efficiency Toolkit. And what this does is, it basically allows you to take the same models, but run them at much better efficiency. How do we do that? There are 2 key components. Number 1, we are able to do a lot more in terms of model compression. And as you can see, what we're able to do is take away redundant parts of the network, redundant layers, and by doing that, we're able to bring in almost 3x model compression, and that's barely trading off 1% of accuracy. And that's, by the way, more than adequate for most of the use cases that are out there on mobile today. The second key component of the toolkit is quantization. Jeff talked about it a little bit also, and as you can see in this particular example, we were able to take a 32-bit model, compress the weights and activations down to 8 bits. Right over there, by being able to do that, we have actually reduced the performance or increased the performance per watt by a factor of 4. Right? Very, very powerful. So you take both of these techniques together and run them on the 865, and we believe with this combination of software, hardware, and toolkits, we have created something amazing. And here is how I'm going to walk you through the use case that we just talked about, which was transcription. But this is what more we can do with it. Absolutely powerful, but bear with me. So let's say you take your phone, your Snapdragon 865 based device. You talk into it. The audio goes into the device through the microphone. It gets converted from analog to digital. The digital then goes into the Snapdragon 865, wakes up our sensing hub. In the sensing hub, you take away echo and noise. Then you actually look for specific keywords, and let's say a particular keyword is detected. Once the keyword detection has happened, you actually wake up the hexagon processor. And within the hexagon processor, the first stage is what we call automatic speech recognition. The speech that just went in just got converted into text. That English text has happened by using convolutional neural networks running on the hexagon processor. Second step, that English text now goes through a transformer neural network, which changes that text into Mandarin text. Now you can see where I'm going with this, right? And now this Mandarin text passes through a 3rd convolutional neural network to be able, rather an LSTM, that converts the text into speech. And you can take that speech, put it into our leading 5G modem, and send it anywhere in the world. What does that mean? It means you can pick up your Snapdragon 865 phone, call anyone in the world, independent of whether they speak your language or not, and have a conversation with them seamlessly. Right? This is the power of the beast, as we call it. And then you can see that that's why we think the Snapdragon 865 is a leading mobile AI platform.
骁龙865是最先进的移动人工智能平台。
Now, if I could speak Chinese, if you notice, if I could speak Chinese, I would speak it this way. So we actually done another artificial intelligence technique that we call audio style transfer. So that speech that came out then actually applies the audio style transfer as to how I would speak it. And that's why what you heard was in my style of speaking. Amazing, isn't it? That's what we can do. All right, so I talked a little bit about 5G and AI come together. Alex and Cristiano also talked about it. Really, these are 2 very synergistic technologies. They work together. 5G makes AI better, and AI makes 5G better. But the key point is, as we continue to do more and more on the device, there is need for ever more AI processing on the device. Why? Because there's a lot of data that needs to be kept on the device for privacy reasons, And in many use cases, like the one that I just showed you, you saw all the processing that needs to happen before even the voice is sent out over the air. It requires extremely low latency. And that's why you need that capability on the device. But now, what does 5G give you? 5G gives you the ability to be able to take that voice or take that processing and through this amazingly fast link and very low latency link, now be able to send some of the work away which is not needed to be done on the device. So you have done a complete paradigm shift where you have this world of distributed intelligence, and intelligence now resides in all parts of the network. So how do 5G and AI come together further? Well, here's a great use case. We have worked with TikTok, one of the most popular apps, and optimized it for 865. And you can envision that you have multiple streams coming onto the device at 720p resolution, as you can see over here. But there is a trick. If you notice, what we are doing is we actually send out that video at 320p resolution. And then we update it to 720p on the device. Why is that powerful? It's powerful because now these 5 or 6 streams that you're sending down don't need to be sent down at 720p resolution. Look at how much data you are saving by not having to send that down at the highest resolution. How do we make that work on 865? Well, it's the same stack that Jeff showed, but now we use the Qualcomm Neural Processing SDK. We use the Hexagon and then Direct, which basically calls the Hexagon processor and runs a very special neural network that we call super resolution. And that super resolution takes every frame and updates it from 320p to 720p. All of it is happening on the device, seamless to the user. Pretty cool, right? Well, I have one more really good one that I want to share with you guys also. So this is a use case we're working with our partners at Loom.ai. I'm sure many of you guys have this situation too. You wake up early in the morning, you have to take a video conference call. You're not really looking that presentable, and you probably don't want to go in front of this camera. Well, the guys at Loom.ai have come up with a great solution to solving this problem. I'd like to welcome the co-founders, Mahesh and Kiran, to talk about how we solve this problem.
Hello, thank you, Ziad, and hi, everybody. We are the Loom AI team. What you're seeing here is my Loomy. It's a 3D avatar, which is superimposed as an avatar layer on live video. As you can see, it is tracking my face, my facial movement, expressions, lip sync, and it provides a powerful new way for people to be present in live video and video conferencing. So let me show you a few avatars that I use, Loomies that I use in my video calls. So this one here is my default Loomy, which I use for day-to-day meetings, conferences like these. Sometimes when I want to have fun with friends and family, I go into this the funny one, a little more over the top. And sometimes I want to be in situations where we like to be visually present, but don't want to show our background. So this is an example of that. And in fact, for folks back home who don't know that this conference is actually happening in sunny Hawaii, I want to take my avatar to a cold ski slope. And that is going to be this one. And that's what it is. So hopefully I'm cold here before jumping back into a 3D room for a meeting here.
Looks like Kiran is having fun here right now. What we have found is that these expressive Loomy avatars increase productivity and collaboration in virtual meetings and conference calls. It is another way to be present and emotionally connected. These Loomies have been built and customized on the fly, on mobile, from a single photograph. Using deep learning and advanced computer graphics techniques, we get these Loomies to mirror the detailed facial movements and capture the facial expressions in real time. What's cool is that the latest 5th generation Qualcomm AI engine on the Snapdragon 865 provides us speed, power efficiency, and compression so that we can enable and take applications like ours to the next level. Please come and see us on the demo floor and at the press lounge. We are also showing a few other applications of these Lumis, one called Lumi Talk, which Lumi Talk is like FaceTime for avatar-to-avatar calls. And yeah, we look forward to see you there. Thank you.
Thank you.
Over to you, Ziad.
Thank you, Loom team. Pretty cool, right? I think I'm going to stick to the Maui weather. I kind of like it better than the ski slopes there. I think much better. So how did we make this use case work on the Snapdragon 865? Very similar approach over here. We're going to take the Qualcomm Neural Processing SDK, which actually calls the hexagon processor in this case, to run 4 different neural networks. In the first step, you actually do face detection within the frame. Then you actually identify certain landmarks on the face to make sure the avatar can fit. You do expression detection, and then finally you replace the face with the avatar. All of it happening seamlessly using the amazing hardware and software that we have on the Snapdragon 865. As we are going further, there are new vectors, new areas where we see AI being applied. And some of the key areas that are developing now is XR, and the avatars that you just saw apply very well to social networking. They apply to XR, and Hugo actually will talk a lot more about this tomorrow. But I want you to leave you with this, that these new use cases, imagine that you're interacting with the world around you using some sort of glasses. Now you interact with the world with your hands. You need absolutely accurate hand detection. You interact with it by talking to the characters in the game. That's natural language processing, right? You are able to now change the textures in the game based on the mood and the situation. You're able to play the game with a bot. All of that is AI being applied on the device. And now on top of that, you can overlay a layer of contextual awareness, and you have a whole set of new use cases that are going to be developed as we go further in time. To recap, we talked about the amazing hardware that we have in 865, the unique deep learning bandwidth compression capability, 15 trillion operations per second capability on the device, and then we have paired that with the best-in-class software. As you saw, we allow access to every level of the stack. And remember that AI is very different from traditional processing. You have to offer a complete solution. You have to offer hardware. You have to offer software, and you have to offer the tools to make all of this work together. I'm absolutely excited as to what our customers and partners are going to be able to build based on the stellar platform that we have put together, and I can't wait to see that. Thank you. And now I'd like to call up PJ to talk about all the amazing stuff that 865 can do for the camera.
Awesome. Thank you, Ziad. Awesome. Hey, thank you for having me, and thank you for being here. And for those of you who know me, I know exactly what you're thinking. This guy loves his ski suits. But you know what? There's one thing I love more than ski suits, and that's cameras. And I used to carry my legacy camera everywhere. And this is when a camera was just one camera, one lens, one image sensor, one image signal processor. And I gotta say, it's really hard to innovate when you only have one camera. Year after year, a new camera would come out, and still just one camera. I don't know, but to me, that's not innovation. You know what innovation is? The future of photography? It's computational photography. It's not one camera, it's 5 cameras. Check out the latest Snapdragon device from Xiaomi. It just launched a month ago. This thing packs 5 cameras, 5 lenses, 5 image sensors, with AI, all working to deliver amazing shots. This thing has a telephoto lens for 5x optical zoom, a portrait lens for 2x optical zoom, a primary camera that delivers 108 megapixel shots. Who does that? We do that. An ultra-wide and a macro lens. It's incredible. The macro lens, you can get up close to tiny objects and snap a photo, and they turn out humongous. I love this thing. But this is the future of photography. Computational photography can deliver all of these features. Portrait mode shots, 4K HDR, it's incredible. But it doesn't just make your photography experience better, it makes all of your apps better. So now in your communication apps, like you just saw, you can use your camera to enhance yourself, have more fun, and you can even add augmented reality to your apps. So features like Google Maps can now use computer vision and augmented reality so you can see your directions right in front of you. This is the future of photography, all powered by Snapdragon. And you know what? It's made such a better world. In our old world, we used to have just one camera per household that maybe one person knew how to use. But in this new world, thanks to Snapdragon, we now have 5 cameras per person. And every person is an amazing photographer when you have Snapdragon. Earlier this year, we ran a photography contest. And Snapdragon users could send in their photos to win a new Snapdragon device and have their photos shown off in Hawaii by your favorite camera marketer. These photos were amazing. Any lighting condition, anywhere in the world, Snapdragon delivers an amazing photo. We've turned the entire world into great photographers, thanks to computational photography. So, Snapdragon has the largest market share in smartphones. And every smartphone has multiple cameras, up to 5 cameras. That means that Qualcomm is powering the most smartphone cameras on the planet. That's right. But it gets better, because you know what? If you want to know what's next in camera innovation, well, you came to the right place. In fact, I know a guy who puts all these amazing camera technologies into Snapdragon, and I want him to show you what's coming next in camera technology. So ladies and gentlemen, please give it up for Senior Director of Product Management for Cameras, but I just call him the king of cameras. Everybody give it up for Judd Heap. Judd, show him what we got.
Appreciate it. Appreciate it. How about PJ's energy level? All right. Thank you very much. So I'll say it's a good thing that we're not at an event like the Grammys, because this morning I came into the green room backstage, and it turns out I'm wearing the exact same shirt as Keith. But it's okay, we both have good taste. So last year, I talked about the fact that I really love my job at Qualcomm because I get to work on camera. And the reason is because camera is how we share our lives and our thoughts with each other. And the great thing about the beast here is that at the heart of the beast is the Spectra 480 ISP. And we've taken a huge step forward in camera technology this year on Spectra 480. It's the biggest update we've ever done to camera. And I want to share it with you. I'm really excited to share it with you, so let's get to it. Thank you. Easily the coolest video of the day. All right, so the Snapdragon Spectra 480 ISP, it has 2 things that are really great. First is gigapixel speed. And what we mean by this is that we can now capture 64 megapixels at 30 frames per second. And you'll hear other people talk about, gigabytes per second, gigabits per second, but in camera, what we're really concerned with is pixels. So that's why we call this the gigapixel speed ISP. The second part is professional quality. And everybody knows if you want to buy a high-end smartphone, you want a professional quality camera, a camera that actually rivals a digital SLR. And that's what we're bringing to you in Snapdragon. Both of these we're bringing to you with the Spectra 480 ISP. So PJ loves ski suits, and I love dogs. So when you take a great picture of your dog, it always comes from pixels. And pixels come from an image sensor. And image sensors today are what are known as Bayer patterns. And these are red, green, green, and blue pixels. And these pixels actually are separated and get clocked into the ISP one by one, from the top left of the image sensor to the bottom right of the image sensor. And this happens at 1 pixel per clock cycle. So it goes through the pipeline one by one. But we knew that if we were going to do some really interesting things and make some big advancements in the Spectra 480 ISP, we would have to do a paradigm shift, do something really, really different with how we handled the pipeline. And so what the Spectra 480 ISP does is it actually clocks in 4 pixels per clock cycle. And that gives us a lot more efficiency. And you may ask why we do this, and there's a few reasons. The first reason is that in a world where everyone is trying to go faster megahertz, we're actually going to slow the clock down. And the reason why we do that is to get a better thermal envelope so that we run cooler. But we can also increase the clock rate and achieve the 2 gigapixel per second mark that I mentioned earlier. But really what this does, this gigapixel speed, is that it enables you to really have some really great new features in the ISP. Because we have some great margin now, we can put in a lot more features. So as Keith mentioned, the Spectra 480 ISP is actually broken into 3 pieces. The first is the high-speed capture block. And this is where the image sensors are connected and all of the data flows in at high speed. The second block is the EVA block, and this is the engine for video analytics. We talked about this last year when we introduced the computer vision ISP. This is where depth maps are created, where objects can be identified, and that can all be used in your videos and in your photos. The third block is the HEIF block. And this is the block that actually compresses, encodes, and stores your photographs. So all of these make up the ISP. And I mentioned that because of the gigapixel speeds in the ISP, we now have the ability to do some really interesting new things. First of all, let's talk about focus. In the past, we could focus on pixels pretty much in the center of the image sensor, the center 1/9 of the image, basically. But now with the extra margin that we have in the gigapixel speed ISP, we can actually use the entire image sensor as focus pixels. So we have 9x, 9 times more focus points than we did in the past, which is huge. That means all of your photographs that you take when you shoot videos, everything can be done as focus from end to end, from end of the image to the other end of the image. There's no having to worry about center weighting for focus. The other thing we did is that, going back to the image sensor we talked about before, there's a new class of image sensors coming out which are called quad CFA image sensors. And instead of looking like this, like a standard Bayer sensor, they look like this. And the pixel pattern is like 4 times larger than it was in the past. And it turns out these sensors are pretty difficult to deal with. They're pretty hard to deal with. One, because they're huge, usually above 48 megapixels. But this pixel pattern is a little bit more difficult to actually handle. So what we've done in the Spectra 480 ISP is that we've hardened logic to actually handle these image sensors with accelerated hardware, which is great because we see that the market is going this way with these types of image sensors as resolutions grow and grow. Another feature that's enabled by the gigapixel speeds in the ISP, noise reduction. Noise reduction is really important, especially in low light. So what we've done is, in the Spectra 480 ISP, we've added specific hardware which is brand new to handle all different types of noise. And again, mainly it's for low light. So static images in low light, you'll see that in the previous generation to the new generation, we've added a brand new noise filter core which is getting rid of coarse grain noise. And again, this is the type of noise that appears in very, very low light photographs. But what you can also see at the same time is that we preserve the edges and details on the text, so you can still read the text here, which is quite unique. It's pretty difficult to actually reduce noise and not lose detail. These cores also enhance contrast. This chart is called a dead leaves chart, and this chart will show really quickly if you're losing detail or losing contrast. So you can see from the previous generation to the Spectra 480 ISP, it looks almost the same. There's actually no detail loss, which is really important. And finally, what we've done for video is that we've added a brand new capability to our temporal filtering core in video, which allows us to process pixels not globally, but on a local level for motion compensation. And what that means is that when you're shooting a video, any local movement in the scene now can actually be processed, whereas before it couldn't. And that results in 40% more pixels that can be processed during video capture than before. And that means all of the videos you shoot will be silky smooth, and they'll have much less noise than before. So we've done some great work here on noise reduction. Talking more about video in particular. In the past, we've been able to capture 4K HDR. We've done this for a while. But many people may not know that you can actually capture snapshots at the same time that you're capturing video. There's always a button there in the viewfinder that you can actually tap and actually capture snapshots at the same time you're shooting video. But in the past, that was pretty much limited to the video resolution. So if you were shooting 4K, your live snapshots, as we call them, were actually only 8 megapixels. But now I'd like to announce that with the Spectra 480 ISP and the gigapixel speeds, we're actually able now to capture 4K video and at the same time capture individual 64 megapixel photographs simultaneously. It's pretty cool. But we didn't stop there. So instead of video mode, if you look at photo mode, we've increased dramatically as well. 200 megapixels. So when you're shooting a photo, you'll be able now to capture at 200 megapixels. And why do we do this? You know, why are the pixels getting so big now? Why is there this race for more pixels? Actually, there's a really good reason for it. And that's if you want to zoom in and get ultra clear detail with digital zoom, the more pixels you have, the better. So you can have very, very sharp detail when you zoom in with digital zoom. And this is not vaporware. So I talk about 200 megapixels, but it's not just theoretical. Qualcomm has partnered with image sensor makers around the world to bring 200 megapixel sensors to market. And so next year, on Snapdragon 865, you'll actually be able to get handsets with 200 megapixel image sensors. And it'll only be supported by Snapdragon 865. Now, I want to talk about some metrics that the gigapixel speeds of the new ISP brings. The first is power savings. I touched on this earlier in the clock rate slide. If you're shooting 4K 60 video, we're actually 16% lower power than we were in the previous generation. So that's a pretty good decrease in power consumption. Also, if you're shooting in low light, because of the extra noise reduction cores I mentioned, you get 18% more texture in your photographs, which is huge. You'll get much more detailed photographs than before. And lastly, as I mentioned, when you're shooting video, you'll be able to process 40% more pixels in the video because we have now local motion compensation being accounted for in the ISP, not just global. I want to shift gears a little bit and talk about something I talked about last year, which is HEIF, or High Efficiency Image File Format. This is something that, again, we talked about last year, and it's a new file format that actually can compress files further than they were before, about 50% more. But as I mentioned last year, that's like the least interesting thing about this file format. The interesting thing is that this file format, as an image container, can give you the ability to have a lot more features. And those features range from being able to shoot and save HDR, being able to mix video with stills, being able to do computer vision and save that information, as well as actually handle a depth map. And that's what I want to talk about today. At Qualcomm, we've worked with Google, and Google has created a brand new standard for the depth map. And that depth map can now be stored within the HEIF container. So if you take a great picture, and this is actually PJ's niece, if you take a great picture, you can use depth information from a depth camera, like a time-of-flight camera or stereo cameras, and you can actually compute and get a really great bokeh result, the blurred background, which everybody loves for portrait photography. But in the past, if you wanted to actually take these two images, they had to be saved separately as two separate JPEGs. But with the HEIF format, these two images can actually be in the same file in the same container, so they're always available. Also, HEIF allows you to add EXIF data. And the EXIF data has always been there as well, but that gives you the ability to know like where the image was shot geographically. It also tells you what the camera was doing at the time, like what the light levels were, what the f-stop was, and what the shutter speed was. All that can be stored in the container as well. But what's new, and what we've done with Google again, is that we've added dynamic depth format. And this is brand new. This is now supported for the first time on Snapdragon in 865. You will be able to not only store images in the HEIF container, EXIF data, but also now the depth map. Thank you. And it's actually about time, because the depth map was always created. Our EVA engine was always creating these depth maps. But they just kind of went away after the image was shot. But now they can be stored. So what that means is that when you shoot a great image, you can go back later and change the focus. You can change the bokeh. You can add depth effects, all after the fact, which is great. So everything I've talked about so far has really focused on the ISP hardware itself, the Spectra 480 ISP. But of course, the beast, Snapdragon 865, is way, way more than that. And the way more than that part is actually our 5th generation AI engine, which Ziad talked about. That consists of the CPU, the GPU, and the DSP. And those work really, really closely with the ISP in 865. And there's a lot of benefits to that. And when they work closely together, we can do some really cool things like segmentation. And you've seen segmentation before. In segmentation, you can do things like I can take a photograph or a video of somebody, I can make them be in color, and everyone else around them we can be in black and white. Or we can take a snapshot of a landscape scene, and I can replace what would be a gray sky with a blue sky. But those are sort of interesting, but maybe a little bit, not so great use cases. What really is interesting and that can be done with this AI engine is much, much deeper than that. We can actually use the AI engine coupled with the ISP to do something new called semantic segmentation. And semantic segmentation actually gives you the ability to improve image quality. It's a lot more than just doing something gimmicky like replacing a sky color or something like that. So I'd like to introduce Toshi Torihara from Morpho, and he's going to tell us about what Morpho is doing in the field of semantic segmentation. Thank you, Toshi. Thank you.
Very honored to be here.
Thank you very much. And Toshi, while they're setting up your demo here, can you tell us a little bit about what Morpho is doing in the area of semantic segmentation and what your take on it is?
Sure. The idea is to bring the best of AI to enhance the image quality using semantic segmentation. And kind of a long name to remember. So we are simply calling it a semantic filter for this presentation.
Great.
So let's get to...
I think your demo's ready. I'll let you have the floor.
So in this demo, we're essentially applying AI segmentation that can identify semantics, or in another word, the meanings to each pixel categories of the object you're trying to take. So in this case, hair, skin, fabric, and background. So this is what the segmentation engine looks like on the back end. In conventional imaging, computational photography is typically applied to the entire image, which can sometimes cause unwanted side effects such as loss of details, textures, and noises in certain areas. Now I'm going to switch mode to a color overlay mode. So semantic filter is able to apply distinct algorithm in different strength level that are most effective to achieve the best image quality as possible. Let's take a look at the video. Conventional imaging, conventional method, imaging algorithms such as noise reduction is being applied to the entire image at same strength level. Notice in some area, some of its details are being lost in this example. Now let's take a look at semantic filter. Semantic filter can solve this problem by understanding the meaning of each pixel categories. Therefore, we can apply the right algorithm at its right place. So whether it is NR, high dynamic range, smoothing, edge sharpening, color enhancements, semantic filter can make the photo super clear with preserved details and end up with final image that you would always want to come back and see, perhaps with a beautified skin. So this feature that combines the best of AI and computational photography is available on Snapdragon 865. And our objective is for the users to maximize the benefit of this feature. So we are willing to customize upon specific needs and use case for further differentiation on the camera. We're looking forward to making the best use of Qualcomm's great 5th generation AI engine to utilize optimization and performance improvement for semantic filter. Thank you.
Thanks, Toshi. Thanks very much. OK, let's talk more about AI. So there's another AI application or use case which is really important to camera. And it was mentioned earlier by Keith and also PJ that the future of smartphone cameras is multiple cameras. And in this case, like an ultra-wide, wide, and telephoto. The problem with these cameras, though, is that if you want to do like a smooth zoom between these cameras that Chris even talked about this morning, it's really difficult to do because the cameras are never exactly aligned. They never actually reproduce the same color. And so you can see here that if you're trying to seamlessly zoom, like a zoom lens, between the ultra-wide, wide, and telephoto cameras, you get these discontinuities, these jumps. So our partners at ArcSoft are using the AI engine to actually solve this problem, to make the actual transition between the ultra-wide, wide, and telephoto cameras seamless, so that it looks very smooth, very fluid, very much like it would with a mechanical zoom lens. So as you can see, this is a huge difference, right? So check this out. ArcSoft is a great partner of ours as well, and they have several demos for camera running in the demo room next door. So I wanted to also talk about video capture. Video capture in the past started out at standard definition, which was about 0.3 megapixels equivalency in terms of photography. We then moved to full HD or 1080p, which is about 2 megapixels. And then we moved to 4K, which we've been talking about for the past few years, which is a little over 8 megapixels. But today we're taking a huge step forward. And now I'm happy to announce that for the first time ever, due to the fact that we're doing 4 pixels per clock and now have the thermal envelope available, we're able to do 8K 30 for the first time ever on a Snapdragon mobile device. Thank you. But it's not just about, oh, I'm sorry. We do have some 8K footage here. So 8K footage, this footage was actually shot on a Snapdragon 865 just this week in Arizona. And this huge LED monitor is awesome, but it's still only 4K. So please go next door. We actually have some 8K, real 8K displays, and you can see the incredible clarity and detail in these video sequences. So check it out. So as I was about to say, it's not just about resolution and size either. It's also about the quality of the pixels that you capture. And we've talked in the past about being able to capture millions of colors, and now billions of colors because of the wide color gamut that you get with 10 bits per color. So again, we've talked about this several times. It's actually called HDR, and when you're shooting in 4K, Snapdragon is able to shoot in 4K HDR, or high dynamic range. And we've done this for generations. We did this back several years ago on 845 with hybrid log gamma. We then moved to HDR10. And then we moved to HDR10+, which we talked about last year. And these are all just incremental steps in improving the quality of the pixels that you have during video. And it's kind of funny that even some of our competitors really have just gotten to 4K, and they're not really even thinking about HDR yet. But today I have an incredible announcement. We are now taking our fourth step, our fourth generation, into HDR video capture. And I think all of you know this logo. So I'd like to announce for the first time ever, not just on a smartphone, but on any consumer device with a camera, Dolby Vision for video capture. And this is going to absolutely change the way that people can shoot video. I mean, it's ultimate video quality right out of the box. So I'd like to introduce Teo O from Dolby Labs, and he's going to tell you a lot more about Dolby Vision for video capture. Thank you very much.
Thank you. Dolby's mission is to deliver transformational experiences. Our promise is to empower creatives through technologies to revolutionize storytelling and entertainment. Today, I'm here to talk to you about how we are doing that with Dolby Vision. Dolby Vision transforms your entertainment experience with ultra-vivid picture that brings content to life, with incredible brightness, contrast, color, and detail. It is the leading imaging solution in market today. We brought first Dolby Vision TV to consumers in 2015. Now, there are hundreds of millions of playback devices across various device types and various pricing points. The creative communities has fully embraced Dolby Vision as the best way to create content. Today, over 2,500 TV shows and movies are available in Dolby Vision from all major Hollywood studios and content creators all around the world. Leading streaming services such as Netflix, Disney+, Apple TV+, and iQIYI are regularly generating original Dolby Vision movies and TV series every week. For consumers, this momentum means more of their favorite shows are in Dolby Vision. The benefit of Dolby Vision does not stop there. We constantly think about how we can continue to push the boundary of innovation. And today, I'm excited to share with you our next frontier for Dolby Vision, user-generated content. Dolby Vision for video capture will be available on Qualcomm's latest Snapdragon 865 mobile platform. It is the world's first chip with Dolby Vision for video capture capability, which will enable mobile device manufacturers the ability to integrate this feature into their future devices. With Dolby Vision video capture, now you can capture and preserve all of brightness, contrast, color, and detail of true-to-life moments. And most importantly, this single file is comparable to all playback devices. From Dolby Vision devices that showcase the incredible imagery that you experienced when you recorded it, to legacy HDR or even SDR devices. With this new capability, Dolby Vision is no longer just for professional creatives. It is for everyone in this room. So capture and share your favorite moment, just as you experience them, with incredible brightness, contrast, color, and detail now possible on Qualcomm's mobile platform. Thank you.
Awesome job, Tae. Thank you. All right. A huge step forward. So I want to talk a little bit more about video capture. We talked about the gigapixel speeds of the ISP unlocking all of these new features. One such feature is actually 4K capture at 120 frames per second. This is brand new. We talked about 8K 30. This is the next step, 4K 120. And what 4K 120 actually brings you is the ability to capture natively in 4K 120 and play it back in 4K 120 on the same device. So as you know, there are displays available today which have broken the 60 hertz barrier, 90 hertz, 120 hertz, 120 frames per second. So now you can record video natively in 120 frames per second, 4K, and play it back on the same display at 120 frames per second, and it's silky smooth. It's incredible. But you can also use this for slow motion. And so slow motion can actually be done now in 4K. Because you're shooting at 120, you can actually play that back at 4x of a difference than 4K 30. And therefore, you get 4x slow-mo in 4K format. So this is also a first. And finally, we want to also talk about something new, which is slow-mo without limits. And what this really means is that in the past, if you wanted to shoot slow-mo, you typically did it in 720p. And we can do 720p 960. And you've actually heard of this in the past. Maybe our competitors have talked about this or even bigger numbers. But I'm here to tell you that those numbers aren't really true. Because typically when anybody has ever gone above 480 frames per second, it's been using frame interpolation, which is actually not really native. In this case, we're actually capturing at 720p 960 native frames per second. So the ISP is actually running this fast. So the other thing about this is that in the past, when you had to do slow motion at 960 or higher, you actually had to capture the moment right when it happened. And you got like no more than like 0.4 seconds. So it was always really hard to capture right what you wanted to capture right at the right time. You end up missing it by like half a second. So I'm here to say that on Snapdragon, with slow-mo without limits, 720p, you can capture a video as long as you want in 960 frames per second. And therefore, you won't ever miss any of the action. It's great. And actually, I think we have some demo footage of this for 720p 960. Oh, can you back up? Sorry, I think I hit the button twice. Let's try that one more time.
Don't stop, don't.
Pretty cool, huh? So now you can shoot 720p 960 for as long as you want. Slow-mo without limits. And finally, 865, the beast. It's packed now with the gigapixel speeds of the Spectra 480 ISP is packed with features. And I'll move out of the way so you guys can take your photographs. But of course, Snapdragon 865 with this new camera will be in consumers' hands next year in 2020. Like I said, all of these great new features, we're so happy to bring these to market. We're so happy to have changed the ISP fundamentally, to have the thermal envelope and the power that we needed to add all of these new features. So we look forward to all of you using them next year. Thank you very much. And now I'd like to bring up Leilani De Leon to talk about Snapdragon Elite Gaming. Thanks again.
Thank you, Judd. Now, this is the part of the presentation that requires some audience participation. So when I say aloha, you're going to say aloha. I want to hear you. I want to hear you loud and proud. I want you to let the state of Hawaii know how happy you are to be here and are going to be ready for the luau tomorrow. And more importantly, if you do it properly, I won't make you do it again. Are you all ready? Yes. Aloha! Mike Kai, very good. Awesome, you guys are ready. Now in Maui, they also have a saying, and that saying is Maui no Ka'oi. And since we're in Maui, I think you should know what it means. So today's Hawaiian word of the day is no Ka'oi. Your turn, no Ka'oi. Awesome. Now no Ka'oi means the best. And so when we say Maui no Ka'oi, we mean Maui is the best, and I would actually have to agree with that, and I think you might have to as well. If you also remember from last year, I introduced Snapdragon Elite Gaming. And I want to pause for a moment and focus on that word elite. What does it mean? In the simplest of terms, elite means best of the best. And so when we say Snapdragon Elite Gaming, we mean the best technologies for gaming, the best gaming experience for gamers. And Snapdragon Elite Gaming transforms mobile devices into powerful gaming machines and brings the best of the best in gaming to everyone. We talk about Snapdragon 865 being the beast. Snapdragon Elite Gaming helps you get into beast mode. So you might ask yourself, does gaming really matter? Well, games account for almost half of all smartphone use and 74% of all App Store spend. That equates to almost $70 billion annually. And these are astonishing numbers. All indicators tell us that those numbers are going to continue to climb. After seeing numbers like that, it's not surprising that mobile gaming has eclipsed digital music and movies combined to lead in the entertainment category. Mobile gaming continues to expand not only in smartphones, but in exciting new devices, such as the Oculus Quest and Unreal XR viewers, where you can actually be in the game. But you'll hear more about XR tomorrow. And gaming will only continue to skyrocket with new cloud gaming platforms like Google Stadia and Microsoft xCloud that gives gamers access to more and more games anytime, anywhere. This just means that more and more mobile is essential, especially for gaming. The generation we're raising now is a mobile-first generation. And I know this because I have a house full of teenagers at home, and they're always on their phones. And I also bet that the generation that they're going to be raising will be a mobile-only generation. So that's something to think about. Not only is gaming taking off as far as gameplay is concerned, it's becoming a cultural and viewing phenomenon with a fan base that rivals professional sports and in-venue musical concerts. In 2020, esports viewership is estimated to be over 500 million people worldwide. Esports now has a bigger viewing audience than most US professional sports teams, and it's growing. Even universities and high schools are investing in and forming competitive esports teams that would rival their athletic programs. Don't take my word for it. To tell you about his own experience in gaming is Ali Kabani, better known as Myth. He's an American Twitch streamer and pro gamer. Myth found success playing Fortnite and joined TSM as their Fortnite captain and their first competitive Fortnite player in early 2018. His Twitch channel has more than 5 million followers, and his social reach is over 19 million and growing. So let me introduce you to Myth. Ladies and gentlemen, give it up for Myth.
Hello. Hi.
Myth, it's great to have you here.
Thank you, thank you.
What do you think of our Snapdragon Summit so far?
It's been nuts, is the word that I would use to describe it. There's so much new tech that I wasn't aware of that's like coming to the space in the next few years thanks to the new processor. And I'm super excited to see all that come into play.
Awesome, we're really happy to have you here. So how did you get started in gaming in the first place?
So initially when I got started into gaming, I grew up in a family of 7 under one household, and a lot of my older siblings actually played video games, a lot of my older brothers. So coming into the family, like basically right as soon as I was able to hold a controller, there was something there for me to hold, and I started playing Xbox, PlayStation right off the rip, and that's basically how I got my foundation.
Sweet, and how did you get into Fortnite and knowing how it's blown up? What is that? Are you like really surprised by all of that?
Oh, I mean, definitely. Not in a million years did I expect Fortnite to have the impact that it's had on the world and in the mobile gaming and just everything. But my introduction into Fortnite actually was, I played a few games from Epic prior and was always following Fortnite before they actually released their Battle Royale version. And then right as soon as their Battle Royale version popped up and I seen the Twitter video, I was like, yo, I gotta hop on this instantly, like ASAP.
So we talked a lot about gaming and how it's blowing up and crazy numbers, surpassing music and movies. Is that just like crazy, like mind-blowing to you?
No, I seen the statistic. I was literally watching behind stage, and it is mind-blowing. I'd never seen those stats before, and it's crazy to see how far gaming is going, especially mobile gaming. So that's super exciting.
So how has the mobile really transformed the gaming industry for you? You stream, you have fans, you engage with them. Like really, what does mobile mean for you?
So for me specifically, I think as someone that is a content creator, a entertainer, somebody that has a lot of influence over people as well, seeing how the new generation of gaming is trending toward a more mobile space is something that's super unique, something that we haven't really seen in the past, 5 to 10 years in gaming. So, traditionally people have been playing on consoles, PCs, but now you have this new generation of people that are kind of starting on their first device, and their first device is a mobile device, which is really, really exciting. So me, I have to kind of take into the consideration that there's going to be new culture that takes into place. A lot of new ways of gaming are starting to be developed, and it's kind of like, I have to get with the new times, or I get left in the past.
We don't want that, right?
No.
So at Qualcomm, we create a lot of the new innovation in gaming that you're going to find in your mobile devices coming up. We have a bunch of engineers that innovate every day. So if you can have a direct line into those engineers and say, hey, yo, here's what we want in mobile gaming moving forward, what would that be?
So for me personally, I think that would be obviously like more frames and higher refresh rates on displays for mobile gaming. Being able to have for example, like a 144 hertz display on my phone would be absolutely crazy. Like being able to crank my 90s in Fortnite would be insane on 144 hertz.
Well, hold that thought. I think you're going to be really excited to hear what we're going to tell you in a few minutes, and everyone else. But in the meantime, thank you so much for coming and sharing your story.
Thank you. Appreciate it. Thank you so much.
Thank you.
Bye-bye. Thank you guys so much.
Give it up for Myth. So the era of mobile gaming has given gamers like Myth, like any of us who game, the freedom to play anywhere, with an experience that rivals the graphics and performance you get from console and PC games. And that's why the rise of a new category of smartphones dedicated to gaming is powered by Qualcomm Snapdragon. Elite gaming devices for gamers who want the best and want to be the best. In a gaming survey earlier this year, we learned that 80% of people who play games on their phones actually want those specialized gaming phones. They want the highest gaming capabilities, and they're willing to pay more for it. Why? Because winning matters. Having the best gaming experience matters. Being the best you can be matters. In a moment, Todd Lemoyne, the technical lead from our gaming engineering team at Qualcomm, will come out and tell you about the exciting new features that Snapdragon Elite Gaming on 865 is going to bring to you. But first, check this out.
Hello. Thank you, Leilani. So I wanted to start today by asking a question. If you could remember back to the favorite gift that you were given as a kid. For me, the clear winner was the original Nintendo Entertainment System. This nondescript gray box seemed like magic to me and turned me into a lifetime gamer. But when I think about where kids today are experiencing video games for the first time, it's overwhelmingly happening on mobile devices that are so far beyond what I had available to me then. So we don't have to go back to the 1980s, though, to think about this comparison. Take a game like Fortnite. This is a game that delivers a virtually identical experience across PC, console, and mobile. This wasn't possible 5 years ago. We work very closely with our friends at Epic Games to optimize their complex rendering pipelines for our hardware. But even then, we occasionally find ourselves bumping into the limits of our hardware. Which is why, with Snapdragon 865 and Elite Gaming, we're pushing beyond the limits. At Qualcomm, it's always been about producing the best possible gaming experience on our platform. With Elite Gaming delivering ultra-smooth gaming at the highest HDR quality and desktop-level features. These are three key areas I want to talk to you about today. Let's start with ultra-smooth gaming. Last year, Qualcomm introduced Game Jank Reducer and Q-Sync. This enhanced the gaming experience at 30 frames per second. But today's Android games are running at over 60 frames per second at the highest possible settings on Snapdragon. So today I'm announcing a new feature called Game Smoother. Game Smoother is a major update to last year's offering. Jank Reducer can now run at any refresh rate, ensuring that frames are delivered to the display in a smooth, predictable manner in sync with what the game is simulating. In addition, I'm really excited to announce a new feature called Adaptive Game Performance Engine. The Adaptive Game Performance Engine is monitoring game workloads in real time at the frame and subframe level, making real-time adjustments to system performance to ensure that these games are running as smooth as possible at the highest quality settings for as long as possible. Game Smoother is going to be a major advantage for gamers on Snapdragon 865. We've also been working very closely with the talented team at PUBG Mobile to enable 90 frames per second gaming modes with PUBG. We believe this is a major trend in gaming that you're going to see a lot more of next year, with the team at PUBG leading the charge. We also knew that for some games, we could achieve 120 frames per second, which is why we've been working very closely with our friends at Tencent to enable 120 frames per second gaming modes for their top games like QQ Speed. But we didn't stop there. We listened to gamers like Myth, and I am so excited to announce, in a first for mobile, support for 144 Hz displays. 144 Hz displays on desktop are the gold standard, especially amongst competitive gamers and esports players. Now, you can have that same 144 Hz display in your pocket. But it's also not just about how fast we're sending frames to the display. We wanted to make sure that those frames had the highest HDR quality and the most vivid color. So last year, Qualcomm introduced true 10-bit HDR gaming for Android, allowing gamers to game in over 1 billion shades of color. We've been working with several of our partners to enable 10-bit HDR gaming, and I'm so excited to announce our partnership with PUBG Mobile to enable 10-bit HDR gaming modes for PUBG. I really want to extend a special thank you to the PUBG Mobile team for all the hard work that they've put into enabling this bleeding-edge feature. The results are spectacular, and I cannot wait for you to see them. There's also a whole bunch of games out there, though, that weren't designed for 10-bit HDR output. So we wanted to take a look at what we could do to improve the visual quality for those games. So today, I'm rolling out a new feature called Game Color Plus. Game Color Plus can enhance the visual fidelity of all current games running on Snapdragon. Importantly, it's powered by our Adreno display processor for the lowest latency, power, and memory bandwidth. And most importantly, no changes to the game code are necessary. Let's take an example and look at what Game Color Plus can do for a game called Lineage 2. So Lineage 2 is an amazingly popular game, generating over $1 billion in revenue with over 30 million active players, with their average players spending 4 hours in a single gaming session. So let's take a look at Game Color Plus being applied. Here you can see one of the key features of Game Color Plus, enhancing the detail in the game. We're also able to use our local tone mapping hardware to increase the brightness and contrast as needed. And again, this is all being performed by our Adreno display processor in real time without adding additional frames of latency. In another example, you can see how we can make the game scenes come alive by boosting the color saturation. Notice how this already compelling scene has become so much more vivid on the display. We importantly also wanted to take a look at how we could optimize the actual rendering of these HDR frames and further increase the visual quality. So today I'm announcing a new hardware feature we call Adreno HDR Fast Blend. Adreno HDR Fast Blend can help accelerate the rendering of all games that are using complex blending to achieve different effects. For example, in games today, particle effects like fire, smoke, snow, these are all achieved by rendering multiple layers of translucency over one another and then blending them together to produce the final result. For example, if you want to throw a lot of bombs and smoke bombs in PUBG Mobile and not have your frame rate tank, you are going to need Adreno HDR Fast Blend. Let's go into a little more detail. What you can see here is a heat map of complexity of this scene. The colors represent the number of layers that are being blended to produce the final output, where blue represents maybe just 1, and white represents over 10 layers that are being blended together. This represents the most complex and challenging portion of the scene to render. With HDR Fast Blend, this scene was originally running at 30 frames per second. But now with this new hardware feature enabled, we're easily hitting 60 frames per second. This is why you need Snapdragon 865. There's some other desktop level features that we're bringing to mobile that I'm really excited to talk to you about today. One of the things PC gamers really, really like about desktop gaming is the control they have over their devices. PC gamers can update their GPU drivers at any time to get the latest possible optimizations and features as they become available. This is just simply not possible on Android today. Well, until now. So today I'm so excited to announce for the first time on Android support for updatable GPU drivers. Our graphics software team has done a tremendous job re-architecting key portions of the graphics driver and working with our partners at Google to ensure users are able to have an easy, seamless experience updating drivers on their devices. You'll be able to simply go to the Google Play Store, download the appropriate GPU driver application, and update your drivers. This allows mobile gamers to get the same performance optimizations and features that their desktop counterparts have been able to get for years. And most importantly, they're able to get these updated drivers well after the phone has launched. Another feature I'm really excited to talk to you about today is desktop forward rendering. Desktop forward rendering allows us to bring advanced shading and lighting post-processing to mobile, which was previously only in the domain of desktop PCs. This is possible due to the additional shader cores that have been added to the Adreno 650 GPU and aggressive software optimizations that the team at Qualcomm has done to take these algorithms, which were designed traditionally for power-hungry, direct render desktop GPUs, and optimize them for low-power, tile-based Adreno renderers. This is going to allow for more realistic and immersive graphics for games. On mobile, let's take an example. On mobile, depth of field is usually implemented by simply blurring out the background. Desktop forward rendering offers a high-fidelity version of this post-processing, where we can take physical camera properties and utilize them to create a more realistic and cinematic version of depth of field. This is a highly desired look in games today. One of the marquee features of desktop forward rendering is the ability to use a ton of dynamic lights. Most mobile rendering pipelines today severely limit the number of dynamic lights that can be applied to the scene due to the increased complexity of calculating the lighting equation for all of these lights and then blending them together. A common technique for optimizing this on desktop is to utilize compute shaders at the front of the pipeline to cull out lights that don't affect individual objects in the scene. This is now possible on Adreno 650 due to our increased compute performance. Along with these dynamic lights, you're of course going to want to have more dynamic shadows. Now, dynamic shadows are created by re-rendering the scene from the point of view of all of the lights in the scene, combining those results together in the final image. These are really heavy workloads to render, but they're not a problem for Snapdragon 865 hardware now. One of the really cool features that I love is called motion blur, desktop motion blur. This is generated by creating a series of motion vectors while rendering the main portions of the scene, and then using those motion vectors later in rendering to appropriately blur the image along the velocity vectors of the objects in the scene. This creates increasing shader complexity and loads up the fragment processing of the GPU. Again, this is not a problem for our Adreno GPUs. As with shadows, planar reflections require rendering the world from an entirely different camera view. For all of the reflecting surfaces, this view needs to be rendered. But most importantly, this view needs to be rendered with all of the same post-processing effects that are applied to the main scene to create a coherent image with the rest of the game scene. Note that on the right, the ball is not only being reflected in the mirror, but you can see that motion blur and HDR tone mapping have been applied so that it matches the results in the rest of the rendering. This is awesome. I'm really excited about this feature. So I'm a gamer, albeit not as good as Myth, but I can dare to dream. But I am so excited for gamers to discover the magic of gaming on Snapdragon 865. With ultra-smooth gaming at the highest HDR quality and desktop-level features, you guys are going to have so much fun playing on Snapdragon 865-based devices. And with that, I'd like to turn it over to Keith Cresson to close out the morning. Thank you.
Good job. All right. I was walking around yesterday and I asked someone, I said, hey, how was day one? He said, it was really good, but maybe a little light on content. So hopefully we made up for that and a little bit more today. So here's a summary of the 865. So let me start with connectivity. The connectivity is all in the X55 modem, okay? The cellular connectivity. So 2G, 3G, 4G, 5G, all in the X55 modem. Cellular functionality is not in the 865, right? It's in the X55 modem in the modem RF system, as we explained. You can use that worldwide. You can use it in 3G regions, 4G regions, 5G regions, right? And it's the best modem in the world, the best connectivity in the world. Performance. We talked about the CPU increased by 25% and the Adreno increased by 25%. But hopefully, you all realize that there's a lot more to a great experience than just the CPU and GPU speeds. It's the experience that's important. That's why we put so much focus on AI. With our 5th generation AI engine, 15 TOPS, twice what we had last year, a sensing hub, an optional camera that supports imaging at less than a milliwatt, the latest LPDDR5 memory, and a lot of enabling. Remember, if you're on Android, you want to download Snapchat, you're going to get a very different experience if you're running Snapchat on a Snapdragon, where you can record right at 30 FIPS versus a non-Snapdragon. Security, super important. Jesse talked about that. All the innovations we have on security, including the alignment we have with Google to make the most secure Android platform in the world. Camera. Judd talked about going from 1 pixel per clock to 4 pixels per clock. So we get 2 gigapixels, which opens up a whole world of possibilities on 64 megapixel captures at 30 frames per second, 200 megapixel resolutions, Dolby Vision capture for the first time ever, 8K capture for the first time ever, and unlimited 960 frames per second record. And then Leilani and Todd talked about gaming. And there's a reason all Android gaming smartphones today are based on Snapdragon, because without a doubt, the best gaming in the world is and continues to be on Snapdragon. So let me step back. At the end of the day yesterday, Alex showed a slide on 865, and he had first. Think about it. The best-in-class connectivity, the best power performance, the best AI, the best camera, and the best gaming. That's why Alex wore his Beast shirt, and that's what we've referred to it all day. We think we've built the most compelling mobile platform in the world. We can't wait till it's in the hands of consumers in Q1 of next year. Thank you very much.